In example 11, we're applying a learning model equation. A common model for learning has an equation similar to k of t, which is equal to negative 2 to the power of negative t plus 1, where k is the percentage of mastery that can be achieved after t practice sessions. This is a transformation of the function f of t, which is equal to 2t, shown in figure 15. What we want to do is we want to sketch the graph of k of t, meaning what would our function look like once we graph this. Now, this equation combines three transformations in one equation. Here are the three transformations. K of t is equal to, well, we apply the negative to the entire function. So it's a vertical reflection on this function. That means we're applying a negative to the outputs. Then the input is t. So we're applying a negative to that, which means we have a horizontal reflection. And then we're adding one, going back to our previous exercises, to then have a vertical shift. Now, we can sketch a graph by applying these transformations one at a time to the original function. So we're going to follow 2 points through each of the three transformations. So on the original function, okay, we're going to choose 2 points on the original function that we can see very clearly. And those 2 points are 0, 1, and 1, 2. Now, we're first going to apply the horizontal reflection. The horizontal reflection is the green, meaning that we're taking the negative value and applying it to the it's the x coordinate or the t coordinate. Okay, so we're going to multiply each x coordinate by a negative value. So let's take a look at 0, 1. Well, if we multiply negative times 0, 0 is neither negative or positive, so it just stays at 0, 1. Now, for the 1 and 2, we're going to multiply the x-coordinate 1 by a negative value to get negative 1, 2. So now when we write 0, 1, and then we graph negative 1, 2, you can see that this graph, okay, was a horizontal reflection from our original function. Okay, now we're going to apply the next transformation. So we're going to apply the vertical reflection. Now, when we apply the vertical reflection, we're multiplying the y-coordinates by a negative value. So now using this from our previous step, we get negative 1, and we have 2, and we have 0, 1. So here are our coordinates. And what we're going to do is we're going to multiply the y-coordinate by a negative value. So it becomes 0, 1 becomes 0, negative 1, and negative 1, 2 now becomes negative 1, negative 2. So now we're going to apply those ordered pairs to a new graph. And so what's happening now is it's reflecting vertically over the x-axis, or in this case, the t-axis. So we plot our points, 0, negative 1, negative 1, negative 2, and there is our transformation. Now we have one more left to do. Finally, we have to apply a vertical shift. So what does that mean? Well, that means we have to add y to the y-coordinates because it's plus 1. So we take our ordered pairs, 0, negative 1. We're going to add 1 to the y-coordinate. Negative 1 plus 1 gives us 0, so we have 0, 0. And over here, we're adding 1 to the y-coordinate. So negative 2 plus 1 gives us negative 1, and then we have negative 1. So now we have our final function where it has an ordered pair of negative 1, 1, and 0, 0. So this means that the original points 0, 1, and 1, 2 had finally become 0, 0, and then 1, 1 after we apply all of those transformations. So in this figure, again, we can see the first graph results from a horizontal reflection, the second results from a vertical reflection, and the third results from a vertical shift up 1 unit. Now again, let's just visually see this on Desmos. Okay, so we first need to write the original function. So we're going to write 2 to the x power. okay? And so what we first did is we applied the horizontal reflection. So we put in negative x. So you can see here that there is our point there. You can see that our other point was, see, 2 and 4 here, or we have 1 and 2, and that turned into once we can hit that there, negative 1, 2. Okay, then we're going to apply a negative to the outside of that 2 when we still have the negative x. So now you can see what's happening. Now we have 0, negative 1. Okay, and then down here, I can make sure that that hits correctly, we have negative 1, negative 2. And then our final function has negative 2 to the power of negative x, and then we're adding 1. So now let's take a look at our function. We still have 0, 0, and then here we have negative 1, negative 1, which is what our points end up being here. So again, you want to make sure you know how to do this by looking at each individual order pairs. So it gives you a better description of how to be able to graph using transformations. And then go to Desmos just to verify your result.